Alright, hi guys, this is Garth again. So as another prerequisite leading up to our ALU circuit in our adder, I want to give a quick tutorial on what a multiplexer is. So in Logisim, if you go into the plexers section, you'll notice a chip for a multiplexer. If we go ahead and place this down here, we'll notice that we've got a couple of inputs. We've got input 0, input 1, and then we've got some output coming out here. And then we've got these two weird lines at the bottom. So what each of these lines are for, one of them is the select line, that's on the left, and the other is the enable line. So the enable line, it just tells us whether or not the mux is turned on or not. So if our mux is turned off, the output's always going to be 0. We're not going to have anything coming out of the mux. So in cases where this is kind of like a light switch. So a mux lets you choose any number of your inputs and spit out that as your final answer. So we've got 4 inputs coming into our mux. We can use our select line to say, oh, I want to spit out the answer for input 2, and that'll be shown in our output. And we use our select line to choose which of the inputs coming into the mux that we want to show as our answer. We choose one of these using the select line. And so I could be choosing input 1 on my select line, but if my enable line is turned off, if my mux is turned off, I'm not going to see anything in my output. So for our purposes, we won't actually be using this enable line at all. So notice that we've got these 2 lines at the bottom of our mux. And if I click on the mux, I've got these options in Logisim. There's an include enable option. And I want to go ahead and set that to no. And so the enable line disappears on the mux, and the mux is always on now. We don't have any option to turn it off. We don't need an option to turn it off. We'll always be using it. So with our default mux in Logisim, we've got 2 inputs coming in. So this is for select bits. We've got 1 select bit, and that affords us 2 inputs. So think of in binary, you've got a number. You've got 1 bit in binary that can be either 0 or 1. That gives you 2 possible combinations, 0 or 1. So with this 1 select bit, that lets us choose between input 0 and input 1, and lets us choose which one we want to show as our final output. So if we go ahead and change this mux, and we change our select bits to 2 select bits, that affords us 4 inputs. And you might say, well, why do we have 4 inputs now? Why don't we have 3 inputs? Since we had 2 inputs before, why do we jump to 4 inputs all of a sudden? Well, binary is base 2, so we had 2 to the power of 1 for 1 select bit. Now we've got, since we've got 2 select bits, it's 2 to the power of 2. So that's 4, and that's why we've got 4 inputs coming in here. So we've got input 0, input 1, input 2, and input 3. This is 4. 0 to 3 is 4 inputs coming into this mux. And so we can actually go ahead and change this, and we could say, oh, let's use 3 select bits on our mux, and now we've got 8 input lines, because 2 to the power of 3, well, that's 8. So we look at our mux, we've got input 0 all the way up to input 7, and so we've got 8 inputs total coming into the mux, and one of those gets selected using our select bit down here at the bottom, and then it gets spit out as the output answer. So if I go ahead and change this mux, I'll go ahead and change it back to, let's change it back to a 2 select bit mux now. So I'll go ahead and set up the inputs here. I'll say this is number A, and it's a 2-bit number. So in Logisim, you've got this option. You can say your data bits. We've got 2 data bits for this number. Actually, let me make it a large number. Let me make it a 4-bit number. And so let me hook this up to our mux. And let me hook up a couple more numbers. So I'll hook up let's say number B. So I'll hook up number B here. Let me just label that number B. And then now let's make a number C and hook that up as well. So I've got number C. Let me change the label. Now let me hook it up to the logic gate. Let me look it up to the mux. Let me move the mux out of the way now so I have a little more room. Now go ahead and hook up the last input gate. And so I'll say this will be number D. So I'll just change the label to number D here, and I'll hook that up to the mux. And so you might be noticing I've got a bunch of orange lines here. And I've got a little error at the bottom. It says incompatible widths. And so what this error means is we've got a 4 here indicating we've got 4 bits coming into this line. This might be new to you. In Logisim, you can actually have more than 1 bit going out over a line. You can have anywhere between 1 and 32 bits going on a single line. They've got this little feature in here. It makes it simpler when you're creating very large circuits and you're transmitting a lot of data on a line. So we've got four bits going on this line, and it's getting fed into the mux, but the mux is only expecting 1 bit coming over a single line. Hence, if you look at the mux and you look at the options in Logisim, we've got data bits here, and that's set to 1. Notice on our input, data bits is set to 4, but on our mux it's set to 1. So we're going to have to change the mux to accept 4 data bits. And once we've done that, once they are matching, once the inputs are matching the same data bit width, the same width as the mux, the orange lines go away and we don't have any errors anymore. So I can go ahead and change the state of these. Say I want number A, I want that to be 1001. Say I want number B to be 0110, and say I want C to be 1111. And I'll just leave D alone. I'll just have that be 0. So now I've got our select bit line. So our mux is expecting 2 select bits. So 2 bits. So I need this to be our selector line. I'll have this say selector. Just label it there. And since I want 2 data bits coming in, I'll go ahead and change that to 2. So I want to hook that up to the mux. And now's a good time to notice that the number of data bits coming in on a line for the mux, that's completely separate with the number of bits for the selector line. So the selector just chooses which line to pick from. It doesn't care how many bits are going across that line, it just wants to pick one to spit out an output. So let me hook up the output to the mux as well. So you'll notice this other error in Logisim. Sometimes it'll change your outputs and it'll put them in 3 state. So you just want to change 3 state to no. And whenever you see that happen, just go ahead and change that. So I've got my output labeled and I just got it hooked up to the mux here. And I've got incompatible widths as well. Our output should be 4 bits as well. Everything in Logisim should be the same bit, the bit width here. So I've got our selector. I've got our selector line here, and our selector line is set to 0, 0. And so that means pick the 0th input line to the mux and spit that out as the answer. So if we look at our 0th input line, the first one here, the one at the very top, that's input 0, and that's for number A, and that's set to 1001. And then we look at our output, and we notice the output is 1001. So when the selector bit is set to 0, 0, it's picking the very first one here, input line 1 in the mux, and spitting that out as the answer. And if we go ahead and change our selector bit to 1, in binary that's 0, 1 for our selector bit here. It'll go ahead and pick number B now. So since this is the input 1 line, that's set to 0, 1, 1, 0, and we look at our output and that's set to the same quantity, 0, 1, 1, 0. So if we want to use line 2 now, we've done line 0 and line 1. We want to use line 2 now. Well, line 2 in binary, that's 1, 0. So we go ahead and look at our selector bit and we change that to 1, 0. And now we're pulling from number C, since this is our 0th input and this is our first input and this is our second input. This is input 2. So the quantity here coming on this line is 1, 1, 1, 1 for number C, and that is our output here. That is the output being shown. So for the last output, number D, that is input 3. So input 3 in binary, that's just 1, 1. So I set 1, 1 as our selector bit, and now it's pulling for number D for our input line, for input 3 going into our mux. It's taking whatever our number is coming in for our input D, and that's being output as our answer here. So just notice that this is a selector. It just chooses which of the input lines we want to say is our output. And I can go ahead and I can change the bits going in here. I could change this to a 5-bit number, and I could have number B be a 5-bit number, and number C I could change that to 5 bits as well. And I could change all of them to 5 bits. And the output would have to be the same bit width. These are all going to have to be the same bit width, the inputs and the outputs. So I go ahead and I change my output here to 5 bits. And then my mux has to transfer this data, and so my mux needs to be modified as well. My mux is dealing with 4 data bits, so basically anywhere I've got a 4 going on here, I want to change that to a 5. So now everything's okay with dealing with 5 bits for the data width. And so this hasn't changed our selector. We've still got 2 bits on the selector, and if we look at our mux, if we look at the settings for our mux, it's still got 2 bits coming into the selector line. When our selector line is 1, 1 in binary, well, that's 3 in decimal. So we were pulling from line 3, so here's input 0, 1, 2, and 3. So we trace our input line here, and we see that the quantity is 0, 0, 0, 0, 0, and that's reflected in the output. So we can go back and we can go ahead and do input 2 here. So we've got input 2, and the quantity for that is 0, 1, 1, 1, 1, and that's the same as our output. And we can go ahead and change to input 1 here, and if we look at that, that's 0, 0, 1, 0, 0, and that's in our output as well. And then we can go ahead and use input 0. Input 0 is right here, and we trace that line back, and we see that's for number A, and that's 0, 1, 0, 0, 1, and that's in our output as well. So it doesn't really matter how many bits you have for your inputs or how many bits you have for your outputs. That's completely separate of how many bits you've got for your selector bit right here. So now for the ALU assignment, what you'll be needing to do, you've got in the assignment they have opcodes listed. So you've got an opcode, and your ALU has to take an opcode. It's 3 bits, and it indicates whether or not you're doing addition or subtraction or multiplication or division. So I think the opcode for addition, that's 0, 0, 0, and the opcode for subtraction is 0, 0, 1. So you want to take the answers coming out of your ALU and you want to pipe them into the mux. And then the opcode just tells the mux which answer to show is the final answer for your ALU's output. So internally, inside your ALU, you've got the answers going on. You've already computed the answers for addition and subtraction and all the expressions you want to be performing, and you're just choosing which answer you finally want to show as your ALU's output. The mux is deciding that with the opcode, so your opcode would literally be the selector bit here. So in the assignment, we've got a 3-bit opcode. So that's going to afford us 8 lines coming into our mux here. So I could go ahead and I could change things to match what you guys are doing in the assignment. I could say, oh, I've got 3 bits coming in on our mux, and then our mux, we would change that to a 3 select bit mux. And then you notice now that I've got a number of different input lines coming in. So if I go ahead and move this around, you'll notice that the lines have connected themselves up to different inputs on the mux, and I don't want that to happen. So if I go ahead, I would delete these lines now, and I'm going to need to redraw them because they've connected themselves to different inputs than they originally were. And so we want to maintain that. We want to make sure that number A is indeed hooked up to the 0th input on the mux, that number D is hooked up to the 3rd input on the mux, and that everything is well. So we take number A and we hook that up here, and we bring that up to our mux here. And then we've got this other line going out, and we bring that to number B. For number C, we bring that up to our mux here, and we hook that into this 2nd input line. And then for our 3rd input line for our mux, we hook that up to our last input for number D. So now we've got a 3-bit mux. This is 3 bits. We're not using the last output bits. We're not using inputs 4, 5, 6, or 7. Though you will in your assignment in your ALU, you'll need to do, there are a lot more mathematical operations than addition, subtraction, multiplication, and division. You'll be doing some bit shifting. There's like right shifting, left shifting. You might have some negation going on. There are a couple of different operations. I think you'll be using you should be using all the 8 inputs on your mux. Just look at the opcodes that the assignment says in Moodle and just use the appropriate functions in Logisim. So I've got my multiplexer here, and I've got 3 input lines, And so I've still got the same thing going on where I've got 000, that picks for number A, and 001, that picks number B. If I have input 2, that's 010 for 2 in binary, and that's picking for number C, and I've got that as my output. And then I've got input line 3 for number D, and that's represented there. Now if I go to input line 4, that's not hooked up to anything on the MUX. So input 4 would be 100. So if I got 100, the output will be an error. I have these X's on the output, and that's just because nothing's hooked up to the MUX. So when you're testing all of the opcodes, and if you see nothing as your output, and you know you've got all of the lines coming into the MUX, just double check your connections and make sure everything's hooked up correctly. You may have some disconnected input lines. In this case, I just don't have a number E going into input 4 on the MUX. I don't have anything there, so that's why the output is displayed as an error. But you'll be using this multiplexer in your ALU, and I'll give an example in a later video showing how this multiplexer is used. See you in the next video.